My name's Adam.
I'm Ryan.
This is Lab 7.
What we want to do is find the distance between these two slits.
So when looking at our air from our slit spacing D, we consider our change in D with respect to our variables we want to see, and that is our fringe spacing and our spacing from source to observant plane. The total air was propagated using root sum square method, and our air in our y sub m value was much smaller than our air in our D value, which makes sense because our dark fringe spacing should be on the order of microns.
The variable that has the most air is large d.
So in this experiment, the ripple tank is set up such that two actuators are in the ripple tank moving in and out of phase, and we'll be comparing the results. When you look at the strobe light of the reflection of the ripples down below, you can see that when it's in phase, the ripples have planar towards the center, and when I switch it, all it does is switch the center planar to the right or left correspondingly. So the fringe lines from our interference patterns correspond to the frequency. So as we increase our frequency, the number of fringe patterns is going to increase. You can see that they're planar, it's pretty much straight towards the center of each of them, and as you go towards the sources, they become more hyperbolic, just like in the theoretical picture. Okay, go for it. When our laser source enters our physical pinhole, it's going to bounce off the surface of Lloyd's mirror and create a virtual pinhole where the interference is observed in our cosine fringes. As we change the vertical height of the mirror to 200 microns, the virtual pinhole will shift twice that distance that we moved. And you can see that our fringe spacing is inversely proportional to our slit spacing, so we can expect the fringe spacing to decrease with D increasing.
The fringe size is equal to the mode number times the distance between the screen, the wavelength, and the spacing between the pinhole and the virtual pinhole.
So we plotted our change in mirror height versus D delta lambda over lambda squared. And you can see by our plot that we have a correlation of 0.99, which means our linear regression fit was really well, but our slope of 4 times 10 to the 7 is off by a factor of 2, because we can expect our slope to be somewhat near 6e to the negative 7.
To reduce error, we could make d much smaller, because the larger d gets, the more prone to error our values are.